like to talk with you about cow farts. I can generally tell when I say that to a class who's actually been in a barn and been on the receiving end of a cow fart, because they're pretty terrible. And typically people who've been around a cow fart, when I say, let's talk about cow farts, go, oh, because they're awful. Yeah. So this is methane, CH4. It's a hydrocarbon. It's the simplest hydrocarbon we can have. So if you had to take a wild guess, if all of your future happiness and a platter of Christmas cookies depended on you guessing what a hydrocarbon was, jot it down. What would you guess? What's a hydrocarbon? So somebody comes up to you and says, I will ensure all of your future happiness and give you this giant plate of Christmas cookies, and you can guess what a hydrocarbon is. Okay. Anyone who I have not heard from yet today, no matter what you're wearing? Ah! Brilliant! You get a plate of cookies and all your future happiness. You can't eat them till after wrestling season, but that's okay. So,
That's the life.
it is a compound that is made up of nothing but hydrogen and carbon. Okay. Have you heard the term hydrocarbon before? No? Okay. You have. Some of you may have. Have you heard the term hydrocarbon economy before?
No.
Okay. So hydrocarbons are things that are made up of only hydrogen and carbon. We like to light them on fire. I'm guessing that most of you got here this morning via hydrocarbons being lit on fire. Did anybody ride their goat or their donkey? Okay. Other than you, yeah. We power vehicles by lighting hydrocarbons on fire. We heat our homes by lighting hydrocarbons on fire, whether it's fuel oil or if you've got a propane furnace, if you have an oil furnace, if you have a natural gas furnace. Anybody have a coal stove? Those are getting rarer and
My
rarer.
grandparents did.
Okay, so coal is a hydrocarbon. Natural gas is a hydrocarbon. Methane, our cow farts, are hydrocarbons. Propane is a hydrocarbon. Gasoline, diesel fuel, these are all hydrocarbons. So we really run our entire economy on lighting hydrocarbons on fire. So it's not even the hydrocarbon economy, it's the lighting hydrocarbons on fire economy. That's kind of the basis of what we're doing. So they're kind of important, and we're going to talk a little bit about hydrocarbons. So let's come back to our methane example. If we light a cow fart on fire, which I do not recommend, no, we're not going to talk about it right now. Okay, so if I light methane on fire, if I ignite methane, what I would like you to write on your paper is what you think it could produce. What could our possible products be? We've got two of them, other than heat and light. So what chemical product could we create out of methane and oxygen? Okay, so somebody who's writing in pen, who's really confident, who's writing in pen out there? No one? Okay, what do you think? Give me one of them. Well, we could if we were going to do a straight up synthesis. If we were going to just combine them, but we have two products here. Okay, what do you think? CO2. CO2. Yes, we get CO2. Commonly, what do we call CO2?
Carbon dioxide.
Carbon dioxide. We get one other product.
Hydrogen.
HOH. H2O.
H2O.
We get H2O. We get water. We get CO2 and water. You light methane on fire, you get CO2 and water. So let's balance this equation real quickly. Okay. You had what, H4O2?
Yeah.
It's okay. All right, so 1, 4, 2, 1, 2, 3. Okay, how can we balance this? Well, our carbons are balanced for now. Let's start out with the fact that we know we're going to have to at least double our water, right? So that gives us 4, and 2 plus 2, that gives us 4. Okay? And at this point, can we double our oxygen without harming any of our other balance?
Yeah.
Yeah. Are we done? That was simple. That was outrageously simple. Okay, good deal. So let's get rid of all this. So that is a balanced equation for the reaction of methane, our simplest possible hydrocarbon. Let's step it up a notch. So hydrocarbons are amazing because you can link an almost infinite number of carbon atoms together. You can form big, long carbon chains. If you have ever used any form of oil in the kitchen, olive oil, corn oil, vegetable oil, peanut oil, any of those are long chains of carbon hooked together. That's all they are. That's what oils are. When we do our soap lab in the next chapter, you'll find that out because you'll be balancing some equations with large hydrocarbons. Okay, our next possible hydrocarbon. Do you have a question? Okay. Would have 2 carbons hooked together, surrounded by hydrogens. And this is actually called ethane, C2H6. This is the other, when we talk about natural gas, like if you live in town, if you live in the city, and you have a gas furnace or a gas stove, you're running on natural gas, the stuff that they're pulling out of the shale layers around here, natural gas is a combination of methane and ethane. So it's a combination of these 2 things. Okay, so if we combust this with some oxygen, we get 2 products. What do you think we get? Okay, give me one of them, David.
Barium.
No. Okay. Give me one of them. What do you think? Simpler. CO2.
Wait.
Huh. Didn't we get that last time?
I'm noticing a pattern.
Guess what else we get?
It's water. Ha. We get ha.
Hold on. We're going to talk about why you get that.
Ha.
You get water. HOH.
Ha.
Huh. Okay, let's balance this one.
Did you say we're going to talk about how you got that?
Yes, we're going to talk about why you can predict that. Okay, we've got 2, 6, 2, 1, 2, 3. Well, we've got this 6 and 2 relationship. We can start off with doubling our carbon because our general rule is start with anything other than hydrogen and oxygen. So let's do that. 4, 5. Still need hydrogen. Now we have 6, 3 plus 4, 7. What's our big trouble here?
Oxygen.
Oxygen, oddball oxygen.
Always be causing trouble.
Always be causing trouble. So let's double our water, shall we?
Shall we?
Okay, so now we're up to 12. 6 plus 4 is 10. And is there any way that we can get 12 hydrogens over here?
No.
Can we get 4 carbons? Sure. 8, 6, 14. What's our coefficient for oxygen? 7. Okay. Clean this up a little bit. Okay. So what we're saying here is that for every 2 moles of ethane that we burn with 7 moles of oxygen, we're going to produce 4 moles of CO2 and 6 moles of water vapor. Okay. Let's get a little crazy, huh? Propane. Propane and propane accessories. How many of you have dealt with propane in your life? Grill, furnace, stove, propane heater in the garage. Okay, good. So what you've actually been dealing with is 3 carbons hooked together. Three carbons hooked together surrounded by hydrogens. That's all you're burning when you light the propane grill. So we have C3H8 plus some amount of O2 yields. What do you think this yields? If you had to take a wild guess for a plate of Christmas cookies, give me one of them. You think CO2 maybe? You'd be right. And what else do you think? If you had to really, really rack your brain.
More methane.
Maybe water? Yeah, water.
Sugar.
Okay. So, if we combust propane, mix it with oxygen in a combustion reaction, we get CO2 and H2O. Let's balance the equation, since we've been having so much fun doing that. Okay. You're going to be able to balance the fourth one in about a half a second. Okay, so first of all, let's address our hydrogen. That gives us 4, 6. Let's address that. And 6 plus 4 is 10. And we're done. Well, that was easy. So if we combust 1 mole of propane, we get 3 moles of CO2, 4 moles of water out. Okay, now I have a challenge for you. Butane. Have any of you ever seen a lighter with liquid fuel? Okay, Zippos, things like that. Those are butane lighters. That is 1 more carbon. So we've gone from 3 carbons, now we have 4 carbons all surrounded by hydrogens. Okay, so this is C4H10. C4H10. We combust it with oxygen. Guess what we get? CO2 and water. Yep, CO2 plus H2O. The reason we know that is because whenever we combust a hydrocarbon, the only products are CO2 and water. That's it. Anytime you combust a simple hydrocarbon, that's all you get out. Okay, now, you get this written down on your paper. I want you to look for patterns in the first 3 and see if you can balance this without counting atoms. We will pause the video while you study it intently.